Hi students. Okay, today your topic is equations reducible to linear form. In the previous lecture we discussing linear differential equation of first order. So now here non-linear equation. So that is equation is reducible to linear form. So the non-linear equation is given equation form Bernoulli's differential equation. This is a non-linear equation. So then how to finding the general solution of non-linear equation, that is the Bernoulli's equation. Okay, first of all see the definition is an equation of the form dx dy by dx plus p of x into y is equal to q of x into y power n. In the right side q of x coefficient y power n and other function is multiplied to the linear equation. So without y power n, that is called linear equation. When q of x is into y power n, this is called linear differential, that is non-linear. That is Bernoulli's differential equation, where p and q are constants or functions of x only, and here y power n is a real number such that n is not equal to 0 and n is not equal to 1. So this is form dx by dy by dx plus p of x into y is equal to q of x into y power n is called Bernoulli's differential equation. So solution of Bernoulli's equation. Okay, first of all the Bernoulli's equation is reducible to linear form. Then after finding the solution of that equation, that is equal to first of all given equation of the form dy by dx plus p of x into y is equal to q of x into y power n. So that is equal to, this is general form Bernoulli's. So next one, multiplying equation 1 by y power minus n, and which is convert to linear form, and y power n is eliminate, do eliminate y power n, and that is equal to multiplying here y power minus n on both sides. That is equal to y power minus n into dy by dx plus p of x into y power 1 minus n is equal to q of x. Y power n is eliminated. So now in this procedure, now substitute here y power 1 minus n is equal to some another variable. That is equal to here, substitute here, put y power 1 minus n is equal to t. So that is equal now differentiation with respect to x. So y power 1 minus n derivative y power minus n into dy by dx, that is equal to, we getting after right outside 1 minus n coefficient right outside, we getting directly 1 by 1 minus into dt by dx. Substituting this value in equation 2. So from equation 2 we getting, so y power minus n into dy by dx is equal, substitute 1 by 1 minus n into dt by dx plus p of x into t is equal to q of x. So again here dt by dx coefficient 1 by 1 minus n, now eliminating 1 minus n, now multiply with the 1 minus n on both sides. That is equal to dt by dx plus 1 minus n into p of x into t is equal to 1 minus n into q of x. Observing this is a linear form only. So that is equal to equation 3 is linear form in t. Solve it, we get general solution to the given equation 1. Again substituting after finding solution y power 1 minus n is equal to t, substitute the t place low, in the t substituting y power 1 minus n, that is the required general solution of Bernoulli's equation. So this is the procedure. So here y power n means in case n is the only not equal 0, not equal 1. In case n is equal 0 or n is equal 1, then could directly linear form. So that is the condition is n is not equal 0 and n is not equal to 1. Okay. See the next one is next one, another form of Bernoulli's differential equation. So this is the first form of this second form. So an equation of the form dx by dy plus p1 of y into x is equal to q1 of y into x power n. This is the second form dx by dy. Here p1 q1 are functions of y. Here q1 coefficient x power n. So here same, n is any real number such that n is not equal to 0 and n is not equal to 1. This is called Bernoulli's differential equation in x. Okay, so now finding the solution of this equation. So solution, the same procedure, the given general form of dx by dy plus p1x is equal to q1 into x power n. So which is converted to linear form. That means in the right side x power n is eliminated. So say multiplying with the x power minus n, that is equal to x power minus n into dx by dy plus p1 into x power 1 minus n is equal to q1 of y. Substituting here x power 1 minus n is equal to t. So after differentiation we getting x power minus n into dx by dy is equal to 1 by 1 minus n into dt by dy, and with respect to differentiation with x y. Okay na, that is equal from equation 2, substitute here in equation 2, 1 by 1 minus n into dt by dy plus p1 of y into t is equal to q1 of y. That is equal to multiply with 1 minus n on both sides. We getting the result is dt by dy plus 1 minus n into p1 of y into t is equal to 1 minus n into q1 of y. This is a linear form. This is the linear differential equation in t. Solve it, we getting the general solution. And in the final solution, substituting again, t is equal to x power 1 minus n. So this is a solution of Bernoulli's equation. Okay. See the problems here. See the first problem. Solve x into dy by dx plus y is equal to x cube into y power 6. So this is a given equation. So observing first of all dy by dx coefficient must be 1 kada, but here extra x. So first eliminating x, first dividing by x, that is equal to dy by dx plus 1 by x into y is equal to x square y power 6. So observing which is the directly Bernoulli's form chudandi. dy by dx plus py is equal to q of x is equal to x square into y power n into y power 6, and n is equal to 6 here. So which is equation 1 reducible to first of all linear form by eliminating y power 6. So that is equal to now multiplying with the y power minus 6. So that is multiplying by y power minus 6. That is equal to y power minus 6 into dy by dx plus 1 by x into y power minus 5 is equal to x square. So now substituting y power minus 5 is equal to t. So that is y power minus 5 is equal to t. Now differentiating with respect to x, that is minus 5 into y power minus 6 into dy by dx is equal to dt by dx. So therefore y power minus 6 is into dy by dx is equal to right outside minus 5 minus 1 by 5 into dt by dx. That is equal from equation 2. So from equation 2 substituting here y power minus 6 into dy by dx is equal to minus 1 by 5 into dt by dx plus 1 by x, y power minus y is equal to t is equal to x square. Again dt by dx coefficient to minus 1 by 5 kada, so right outside, that is equal to dt by dx minus 5 by x into t is equal to minus 5x square. So observing equation 3 is linear differential equation andi, which is linear equation in form dy by dx plus py is equal to q of x, but y is equal to t in t. So here p is equal to minus 5 by x, q is equal to minus 5x square. So that is equal to, now finding the integrating factor, e power integration of p dx, that is equal to e power integration of minus 5 by x into dx, that is equal to e power minus log x, that is equal to simplification x power minus 5. So that is equal to here solution of equation 3 y into kada, but y is equal to t. So t into integrating factor here. So t into integrating factor, integration of q of x, integrating factor dx plus c. So t into integrating factor x power minus 5, integration of minus 5 into x square. So integrating factor x power minus 5 into dx plus c. So that is equal to a simplification of finding the integration of this value, minus 5 into integration of x power minus 3 that is minus 1 by 2x square, that is equal to 5 by 2x square plus c, but t is equal to, t substituting, t is equal to y power minus 5, that is y power minus 5 is equal to t, so y power minus 5 into x power minus 5 is equal to 5 by 2x square plus c, that is equal, simplification is right outside 2 into here, 2 is equal to 5 x cube y power 5 plus 2c x power 5 y power 5. This is the solution of the given Bernoulli's equation. Okay. Okay. See the second example here. Dy by dx minus y tan x is equal to minus y square secant x. So see that directly here Bernoulli's equation and so dy by dx plus py is equal to q of x into y power n. So that is equal to, so now here eliminating y power 2 kada. So now multiplying with y power minus 2 on both sides, that is equal to y power minus 2 into dy by dx minus y power minus 1 into tan x is equal to minus secant x. So now substituting here y power minus 1 is equal to t, that is equal to differentiation with respect to x minus y power minus 2 into dy by dx is equal to dt by dx. So minus right outside y power minus 2 into dy by dx is equal to minus dt by dx. Substituting in equation 2, so that is equal to here minus dt by dx minus tan x into t is equal to minus secant x. So here coefficient minus 1 and now eliminating minus 1 multiply with the minus, that is equal to dt by dx plus tan x into t is equal to secant x. So observing which is a linear differential equation in t. No? So dy by dx plus py is equal to q of x, where p is equal to tan x, q of x is equal to secant x. Now finding the integrating factor. So that is equal to integrating factor e power integration of p dx, that is equal to e power integration of tan x dx, that is equal to e power integration of tan x log secant x, and a base e, that is equal to secant x. Therefore general solution of equation 3, so t into integrating factor is equal to integration of q into integrating factor dx plus c, that is t into secant x is equal to integration of secant x into secant x dx plus c. So integration of secant square x dx tan x, that is equal to, but t is equal to y power minus 1 substitute, that is equal to y power minus 1 into secant x is equal to tan x plus c. So this is the general solution of the given equation. See the next example. Okay, solve dy by dx into x square y cube plus xy is equal to 1. So that is equal to, there is no directly dy by dx can be right form only. So okay na. So now using here second form of Bernoulli's, that is dx by dy form. So dy by dx right outside dx by dy. So dx by dy is equal to x square y cube plus xy. But we want in the Bernoulli's form another form, dx by dy plus p1 x kada, and x term. This is x term right outside, that is equal to dx by dy minus yx is equal to x square y cube, and dx by dy plus p1x is equal to q1 is the function of y kada. So this is the q1 y cube, this is x power n. No? So that is the general form here. So that is equal, now eliminating x square eliminating. So now multiplying with the x power minus 2. So multiply with the x power minus 2, that is equal to x power minus 2 into dx by dy minus y into x power minus 1 is equal to y cube. So now we are substituting here x power minus 1 is equal to t. X power minus 1 is equal to t. Now differentiation with respect to y. minus x power minus 2 into dx by dy is equal to dt by dy. Here minus coefficient right outside, x power minus 2 into dx by dy is equal to minus dt by dy. So from equation 2, both are substituting in equation 2. So minus dt by dy minus yt is equal to y cube. So now minus common. So dt by dy plus yt is equal to minus y cube. So this is linear form only in t. That is equal to, which is a linear form, dx by dy plus p1x is equal to q1y. That is equal to, where p1 is equal to y, q1 is equal to minus y cube. Now finding the integrating factor. So e power integration of y dy, that is equal to integration of y square by 2. So now general solution of equation 3. Yeah, this is a general solution, substituting t into integrating factor of e power y square by 2, that is equal to q1 is equal to minus y cube, integrating factor e power y square by 2. So now substitution method, here y square by 2 is equal to u, that is equal to, now differentiation with respect to y and u. So 2y, 2 cancelled, y into dy is equal to du. So that is equal, substitute here integration of, here minus, y cube means y square into y. Y square is equal to 2u. No? So next to e power y square by 2 kada, ante e power u. Remaining y into dy is equal to du. So 2u into e power u, again by parts method, minus 2 into e power u minus 2 into e power u, that is equal to, u is equal, replacing again, u is equal to y square by 2, get 2 common, and e power y square by 2 common, that is minus y square by 2 plus 1 plus c. Now simplification is, again t is equal, substituting x power minus 1. So that is equal to x power minus 1 into e power y square by 2 is equal to, get 2 common, 2 LCM, 2 cancel, minus y square plus 2 into e power y square by 2 plus c. This is the solution of the given equation. Okay. So thank you. For more videos, please do subscribe my channel, like and share it. This is the Bernoulli's equation and solution of the Bernoulli's form. Okay na? Thank you.